Alright, we were in the middle of problem 10 when our video stopped, and so let's go back and get finished with it. We have the equation 0 equals p squared minus 14p plus 48, and I have to factor that. So I have to think what multiplies to give me positive 48, right here, and adds up to negative 14 from here in the middle. Negative 6 and negative 8. So p squared minus 6p minus 8p plus 48. I take my first two terms and I have a p that goes into both of those, so I get p minus 6. I look at both of these and I see 8, but since I want this to be a positive, I'm going to take out a negative 8, which leaves me negative 6. Now my parentheses are exactly the same, which is what I need. So I factor that parenthesis and I have p minus 6 and p minus 8. My problem, therefore, p equals 6 and p equals 8. I need to go back and double check my problem to make sure both work in my equation. So I have the square root of 48 plus 14 times 6, and that's supposed to equal 6. Oh, that's a negative 48, sorry. That gives me 64, so negative 48 plus 64 is negative 48, and that is positive 16. The square root of 16 is not 6. So that does not work. Unless I have done something incorrect. Oh, that's 14. I am so sorry. That's 84, not 64. That was my mistake. I apologize. Made a mathematical error right there. It's negative 48 and positive 84, which is indeed 36. Thought something looked wrong. So square root of 36. So yes, this checks, and that answer works. I also need to put in my 8. So negative 48 plus 14 times 8, and it's supposed to equal 8. Oh, I'm sorry, I'm off the screen. It has to equal 8. That gives me 32, 3 by 3, 8, 19, 11, plus negative 48. So 64. The square root of 64 is indeed 8. So my problem checks, and both answers work for that problem. Excellent. Now, let's go to problem number 11. Oh, right there it is. Problem number 11. I have a square root, so I have to square both sides. So I get v squared is equal to 6 minus v. Because it's a quadratic, I need it to equal 0, so I'm going to add my v to both sides and subtract the 6. So I get v squared plus v minus 6 equals 0. And I've got to think, what multiplies give me negative 6 and adds up to 1? Well, that's going to be a positive 3 and a negative 2. So my problem, v squared minus 2v plus 3v minus 6 equals 0. My first two, they have a v in common, so I have v minus 2. My last two here have a 3 in common. That leaves me with v minus 2. My parentheses are the same, so I have v minus 2. And v plus 3. Now, when I solve this, this gives me v equals 2 and v equals negative 3. When I plug these back in, I have 2 equals the square root of 6 minus 2. Well, that's 4. The square root of 4 is 2, so that works. This is a solution. And negative 3. Negative 3 is equal to the square root of 6 minus a negative 3. Negative 3 equals the square root of 9. That is not correct. Therefore, this is an extraneous solution. It is not acceptable for our problem. Number 11 has one solution, and it is 2. Problem number 12. This problem is still a radical problem, but it's the power is written as a rational expression, a rational power. So to get rid of this, I raise both sides to the reciprocal power. I flip my power over and raise both sides to the 2/3 power. When I do that, my powers, they multiply together, and my 2's will cancel, my 3's will cancel. I have 11v minus 2 equals 512 to the 2/3 power. 5, and that will give me 64. And now I have to keep solving. I add 2 to both sides. Gives me 66 is equal to 11v. Divide by 11. And v equals 6. And there's my solution. Number 13, very similar. I've got to get this a to the 1/3 by itself. So I have to subtract 5 from both sides. So I have a to the 1/3 power is equal to 5. To get rid of the 1/3 power, I'm going to raise both sides to the 3/1, which is just 3. So this gives me a equals 5 to the 3rd power, which is 125. And I have my 2 solutions there. Now, number 14, which is writing our problem in radical form. Sorry, there it is. Writing it in radical form. Because this 2 is on the bottom, it tells me it is a square root. I'm going to take the 6x and put it on the inside. I can use parentheses, but I don't have to. And now the whole thing is going to be raised to whatever's on the top, which is the 5th power. And that's how I will write it in radical form. Number 15. Because of the 4 here on bottom, that tells me it is a 4th root. So my 4 goes in this little space, and it's a little smaller. My 5k goes inside the radical, and it's raised to whatever the numerator is, and in this case, it's a 3. This is radical form. This is exponential form. So number 16. I have it in radical form, and I need to write it in exponential. Well, my index right here is a 2 because it's a square root, and that becomes my denominator. So I take what's inside, 6x, put it in parentheses. Now my power. What's on the outside goes on top. My index, the 2, goes on bottom. And that's exponential form. Number 17. Again, what's inside the radical is going to go in my parenthesis, and my exponent is going to be based on the index and the power on the outside. This outside power goes on top, the index goes on bottom. And there's my problem. Now, our next area is writing the inverse function. I gave you 3 steps. First thing, use this g of x and change it to a y. Now swap the x and the y. Third step, solve for y. So I have to divide by 4 because that says multiply. That cancels. So I get y equals x over 4. To write it in inverse form, that's g, the inverse. That negative 1 right there means inverse of g of x, and that equals x over 4. And there's my inverse function. All Alright, same problem here with number 19. I'm going to change this to a y equals 1/4 x plus 3/4. That's step 1. Step 2 is to swap the x and the y. Now I need a little more room, so I'm going to rewrite it up here. X equals 1/4 y plus 3/4. I've got to get the y by itself. So my first step is going to be to subtract this 3/4. Oops, sorry. So I have x minus 3/4 equals 1/4 y. To get rid of 1/4, I multiply by the reciprocal, which means I flip it over. And so I'm going to multiply by 4 over 1. I'm going to multiply everything over here by that. My 4's cancel, 1's cancel, so I get y equals. Now I'm going to do my distributive property here. 4 times x, 4x, and 4 times 3/4. My 4's will cancel, and I'm left with negative 3 over 1, which is just negative 3. So this is my inverse function. To write it in our little fancy handwriting there, it's the inverse of f of x is equal to 4x minus 3. And there is my inverse function for number 19. Well, number 20, we are still doing the inverse. Excuse me. And we need to graph it as well. To graph this function and its inverse. Well, now this is a cubed root, so it's the wiggle. Opposite, keep. So negative 3, 1. Negative 3, positive 1. I'm going to go 1 in each direction, and it creates my wiggle. Alright, this is my f of x. Now I need to find the inverse. So I'm going to slide over here. My function says f of x equals the cubed root of x plus 3 plus 1. To find its inverse, I've got to find the inverse. Change this to my y. Now swap the x and the y. And I'm going to work my way to getting the y by itself. I go from the outside to the inside. So first I need to get rid of the 1. So I have x minus 1 is equal to the cubed root of y plus 3. To get rid of this cubed root, I'm going to cube both sides. Raise it to the 3rd power. Now this could be multiplied out, but I do not want to do that. I want to leave it as x minus 1 to the 3rd power equals. Now, on the right side, this 3, the power of 3, and the cubed root are inverses, so they cancel each other out, and I'm left with y plus 3. I'm going to subtract my 3, and it will go on the outside of this parenthesis, so I have x minus 1 cubed minus 3 equals y. And again, using my fancy little inverse, the inverse of f of x is equal to x minus 1 cubed minus 3. Now to graph this, opposite, keep. If it's in the parenthesis, you always use the opposite. So that's going to be at 1, negative 3. Alright, so let's go back to our graph. 1, negative 3, right here. Now, my function, there's a 1 right here, so I'm still going up 1 and over 1, and down 1 and back 1. And my graph is going to go this way. Nope, I missed showing it to you, sorry. And that's my inverse function. If I look real carefully, if I put this little dotted line in here,